All right, we're in the home stretch here. Moving on to question 76. What force keeps mercury in a barometer? Now let's talk about what a barometer is. With a barometer, we have a tube that is about 80 centimeters high, and it is filled with mercury. It's then placed into a bowl of mercury. So the mercury level in the bowl is above the bottom of the tube, the mouth of the tube. Okay, air pressure is pushing on that mercury in the bowl, and that mercury will in turn push up on the mercury inside of the tube. Okay, Newton's third law, every action has an equal and opposite reaction. Now, if we increase the amount of energy or the pressure of the air pushing down, that's going to cause that level to rise. So that's going to be higher pressure. If the next day comes along and we have half as much pressure pushing, then our level will fall because it can't hold it up as much. All right? So basically, what keeps the mercury in the barometer? Air pressure. And the air is pushing on the bowl of mercury, or pool. 77, Boyle's law. The equation of Boyle's law. P1V1 equals P2V2. It's the relationship of pressure and volume. As the pressure goes up, the volume goes down. Number 78. Let's say you have a gas at 290 degrees Kelvin and 1 atmosphere. If the temperature is doubled, what will the volume of the gas do? Well, now we're using temperature and pressure. So that would be Gay-Lussac's law. Pressure 1 over temperature 1 is equal to pressure 2 over temperature 2. So we have 290 and 1 atmosphere. We're going to double our pressure, so that is going to be 380 Kelvin, and we're going to solve for our pressure. 380 divided by 290, it'll be 1.31 atmospheres. How many moles of gas do you have if it is in a 25-liter tank at 15 atmospheres and the temperature is 25 degrees Celsius? We'll use PV equals nRT. We're solving for moles, and moles is equal to PV over RT. Our pressure is 15 atmospheres. Our volume is 25 liters. 0.0821 is our gas constant, and our temperature is 25 plus 273, 298. Plug and chug. 15 times 25 divided by 298. 15.3 moles, if I did my math right. Number 80, what volume would 1 mole of a gas at STP occupy? Well, PV equals nRT. 1 mole, we want to know volume, so we're going to solve for P or V. 1 mole, 0.082 liter atmospheres over mole Kelvin. Temperature is 273 because it's STP. Pressure is 1 atmosphere. And we end up with 22.4 liters. And that is for any gas. That is Avogadro's rule. Ideal gases are gases that do not have any intermolecular forces. The only way, well, not the only way, but if you're dealing with real gases, you're going to have issues when you have high pressure or low temperature. So, ideal gases, real gases, if they're close together, they're going to have intermolecular forces. That's going to happen at high pressure or low temperature. All right, phase change diagram I have on a different page. If we look at this, lowest temperature, we know we've got to start with solids in this quadrant. All right. Now, as temperature goes up, if the pressure stays low, solids will change directly to gases. But as pressure increases and temperature increases, we can have liquids exist. Okay? The triple point is where you have all three phases. The critical point is the point at which you can no longer compress a gas. This line here is if you're heating it, it's melting. If you're cooling it, it's freezing. Oh, no, that's wrong. If you're heating it, it's subliming, like dry ice. And it is deposition if you are cooling it. The line between solids and liquids obviously is melting and freezing, vaporizing, this line here, and condensing. The last question asks, which would effuse most quickly through a porous barrier? The smallest gas will fuse the quickest. The ratio is the rate of one compared to the rate of the second is equal to the inverse of the square root of their molar masses. Okay, so the smaller one's going to have a heavier mass, or the smaller rate, slower rate, if you will. So which one of these has the least mass? Chlorine's going to be 71. Krypton's mass is going to be in the 70s. I'm looking it up if you're wondering why I'm pausing. Krypton's 83. Argon is 40. Xenon is 131. And bromine is going to be 159. So the lowest here is going to be our argon. All right, there you go. Hopefully that will help you succeed on the